Okay, we're looking at homework from section 4.2. This is question number 11. 22% of U.S. adults say they are more likely to make purchases during a sales tax holiday. You randomly select 10 adults. Find the probability that the number of adults who say they are more likely to make purchases during a sales tax holiday is A, exactly 2, B, more than 2, and C, between 2 and 5 inclusive. So let's start with part A. This is binomial because either a person says they're more likely to make a purchase during a sales tax holiday or they don't say that. There's two possible outcomes there. So we're going to be using the binomial formula. And so to use the binomial formula, we need to know the value of n. N is 10 because we're selecting 10 adults. And then P, the probability of finding somebody who is more likely to make a purchase, is 0.22. So, by the formula, P of x, probability of x occurrences, is given by NCx, P to the x, Q to the n minus x. So, if P is 0.22, what is Q? Well, we find Q by doing 1 minus P. 1 minus 0.22 is 0.78. We plug those in. Probability of 2 is 10C2, 0.22 to the second, 0.78 to the 10 minus 2, which is 45. 10C2 is 45 times 0.22 to the second times 0.78 to the eighth. And when we multiply that all out, we get 0.2984109099 rounded to the nearest thousandth. That's 0.298. Now we could have also done this on the calculator. If we were using the TI-8384 graphing calculator, then what we would enter is binom PDF, the binomial probability distribution function, 10, 0.22, 2. So the 10 represents the n, the 0.22 is the p, so it's always n, p, whatever x value you want to plug in. So because we wanted to know the probability of 2, the last number that we typed in was 2. We press enter, and it gives us the exact same answer, which is 0.298. So that's part A. For part B, we want the probability greater than 2. This one we're really going to need the calculator for, because if we would do the process that we just did for part A, we would have to do that process 8 times, because greater than 2, when you're talking about n going all the way up to 10, greater than 2 represents 3, 4, 5, 6, 7, 8, 9, and 10. We would have to plug in each one of those numbers just like we did in part A. So we'd have to do 8 separate part A's basically. If we use the calculator, it becomes much simpler. So we would have to add the probability of 3 plus the probability of 4 plus the probability of 5 all the way up to the probability of 10. So much easier if we use the calculator. When we want to add things, instead of using the binomial PDF function, we're going to use the binom CDF function. C stands for cumulative. Cumulative means we're adding things up. The binomial CDF function can be used to add binomial probabilities, and the CDF function always starts when x is 0 and continues until you tell it to stop. So it'll start by plugging in x equals 0, then x equals 1, then x equals 2, then x equals 3, and you have to tell it what the last value you want added is. So this sum for x greater than 2 doesn't start at 0 because 0 is not greater than 2. This sum actually starts at 3. Right, we saw it was the probability of 3 plus the probability of 4 all the way up to the probability of 10. That means we're looking at a complement here. We're going to have to do a subtraction. The sum we want doesn't include x values from 0 to 2. So that's what we have to subtract. We're going to use this binomial CDF function to add up the binomial values from 0 to 2 and then subtract from 1, and that'll give us the binomial values from 3 all the way up to 10. So we're doing 1 minus the binomial CDF of 10, 0.22, 2. Again, it's n and then p and then the last value of x we want added. When we plug that in, we get 0.38311977071, rounded to the nearest thousandth, is 0.383. For part C, we're also going to do the binomial CDF function, but we're going to do it twice. Okay? If we did the part A idea, we would add 4 different probabilities. The probability of 2, plus the probability of 3, plus the probability of 4, plus the probability of 5. This calculator will do it for us. So how do we do that? Again, this is a sum that doesn't start at 0. The binomial CDF function can help us though. So if you think about this sum adds values between 2 non-zero values. So we're going to actually have to do 2 binomial CDFs subtracted from one another. The sum we want includes values from 2 to 5. So that's what we have to include in our sum. So how do we do that? Well, we're going to do binomial CDF 10, 0.22, 5 minus binomial CDF 10, 0.22, 1. Why does that work? Well, the binomial CDF 10, 0.22, 5 adds all the way from 0, so it's probability of 0, probability of 1, probability of 2, probability of 3, probability of 4, and probability of 5 all added together. The binomial CDF 10, 0.22, 1 only adds the 0 and the 1. So you can see that if we subtract the probability in 0, the probability of 1, from that other sum that has 0 through 5, we'd be left with 2, 3, 4, and 5 being added together, which is what we want. So that ends up being 0.3727261393, rounded to the nearest thousandth, is 0.373. And that's your answer to part C. And those are your answers.